Hi, I am Ameya Prabhu, and I will be presenting our work, Rapid Adaptation and Online Continual Learning. Are we evaluating it right? Let's dive in. First, I briefly describe online continual learning. We have a stream which is presenting us samples. We first evaluate, that is, we get a set of samples, we generate predictions, the stream reveals true labels, and we compute our accuracy, our online accuracy. And then we train using these labeled samples. And then this process repeats again. Our work tackles this setting where this stream has label correlations, and we see that this is very common. We study two large datasets and find out whether label correlations exist. These simulate different servers where data is arriving naturally. Let's look at these samples. We see that these samples are highly correlated. It is as if someone took multiple photos and uploaded all of them. And this is very common in real world. Our hypothesis is that these label correlations really impact online learning performance and makes them select really bad classifiers. We evaluate this by first testing a blind classifier. A blind classifier is something which does not see any images, but sees only the past labels and predicts the most common label. We see that a blind classifier has highly non-trivial performance. This means that even it can exploit label correlations, and this quantifies the degree of label correlations present. Can we abuse these label correlations? That is, can we have a very bad method perform really well on online learning or on online accuracy metric? We show that just by using FIFO sampling to overfit on the latest batch and using linear layer only training to prevent representation collapse is sufficient to get us really high performance. We see that our performance is way higher than state-of-the-art methods. This means that by just designing a method which overfits, we perform really well on online accuracy, and hence this metric incentivizes bad algorithms. And this is really bad. We evaluate whether the performance is due to sampling or just fine-tuning the linear layer. And we find that it is due to sampling. If we remove the FIFO sampling, then the performance drops significantly, which means that the performance gain was due to overfitting on the latest batch. What are the possible solutions? Can we change the dataset to remove correlations? The dataset is merely reflective of what we encounter in real life. We cannot change the datasets. What instead we can do is we can change how we evaluate rapid adaptation. Instead of evaluating in the very next batch, we propose that we evaluate in the future batch which is free from these correlations. And this will give us algorithms which reliably evaluate rapid adaptation without falling into this trap of correlations. How do we compute how near in the future to look? We say that we should delay the evaluation until the blind classifier drops to random. So we just see the time delay required for the blind classifier to go from 0 to random, and we delay it by this amount. This is the minimal delay that we can use. And we evaluate on these metrics. Which methods perform well? We see that in fast stream, the ACM method, which only trains KNN, performs really well across datasets. And in slow stream, where we have more compute, offline training methods such as ER, ACE perform the best. Notice that these methods are offline. These do not do online learning. They don't encounter the latest samples. They just train on past samples. This is very surprising. And we see that now information retention and rapid adaptation are correlated, which was inversely before. This is due to fixing the metric. So in essence, information retention and adaptation are more linked than we thought. And in fast stream, simple baselines outperform advanced OCL methods. Thank you.